In this video, I want to introduce conditional probability. Previously, I considered a data set about newspaper subscriber information to illustrate a counting technique. I want to look at this data set again, but I've modified the numbers to make the arithmetic a little easier. The situation is you've got a community of 400,000 households. The local newspaper knows that 240,000 take the Sunday edition, 160,000 take the daily edition, and then the rest of the numbers are as you see them. Now, first let's calculate a typical kind of easy probability. Supposing we want to know the probability or the percent of households which take the daily paper, which I would write as probability of daily. And we need that's pretty easy to look at. You look at 160 over the 400. Both numbers are in thousands, and that's easily seen to be 40%. Let's look at the probability or the percent of households that people take the Sunday paper. Well, that's going to be 240 out of the 400,000 households. So we can write that and calculate that to be 60%. And we can even do a little more, supposing we wanted to see how many people, what proportion of the people take both the daily and Sunday. Now, newspapers would be interested in that information. And we find that by looking at the appropriate cell, the intersection of the daily row and the Sunday column, and see that 100,000 out of the 400,000 subscribe to both editions, and that's 25%. But now let's add some information. In other words, let's look at, say, the probability or the percentage of households which take the daily paper, take the Sunday paper, given they take the daily. In other words, now we've introduced an extra little, I'm going to read it here, kind of a quantification. Namely, we're assuming people take the daily paper, and we want to know what fraction of the people who take the daily paper here are going to end up taking the Sunday paper. So we're going to be looking at this total set, and we're not looking at all households. We're only looking at the total of 160 households here. And so this fraction, this probability, is going to be the Sunday subscribers are 100,000 out of a total of 160 subscribers. Well, that's going to be what, 5 over 8, which comes out to be 62.5%. So notice that we see that there was 60% of the people just took the Sunday paper, 60% of the households, but that if we restricted ourselves to the people who were daily subscribers, that actually a slightly higher percent of those people. Now, this is what's called a conditional probability, this type of a probability here. And it's designated with the following notation. Usually you'd say the probability of Sunday, and we use a slash line here to designate the given the daily. And that probability, of course, would be the same. This is just the notation. Now, we can actually state this in English in several different ways, and it's useful to be aware of these things. For example, we could say, the question could read, what's the probability that if a household takes, I'll say takes instead of subscribes, takes the daily edition, then they take the Sunday edition. Okay, now notice again, just as in the previous situation there, we are, when you look at this, we see that there is an assumption or a restriction made on uh, the event that we're looking for, namely that they take the Sunday. Namely, we're again restricting them to the daily subscribers. Another way of stating it that may not be all that apparent would be something like the probability that a household that takes the daily edition takes the Sunday. Okay, now again, when you read this, you've got to understand that there is a restriction being placed on the people you're looking at, namely you're looking at the household that takes the daily. This is sort of the subject of this sentence, just like the assumption here in this conditional is that a household takes the daily. Here the subject is the households that take the daily, and then you want to know something about them. Again, this is what makes this a conditional probability. Now, there's actually a relationship between the numbers that I've listed here. It might be better to look at these in terms of a little diagram. So if we make a graph that allows us to look at, say, the daily first, and here's the non-daily. Okay, and we saw from the first calculation that 40% of the households took the daily. So what we've done here, and that means 60 don't, what we've done here is we've looked at a splitting up of the of events here, then the daily and non-dailies. And now let's look at a second layer of this graph diagram, and that one will deal with the Sunday subscribers. Here's the Sunday, and there's the non-Sundays, and here again Sundays and non-Sundays. We're not going to need all of these now. What does this branch of the mean? Well, if you're along on this branch, it assumes you take the daily and then wants to know the relationship with Sunday. So this is exactly the conditional probability. The probability that you take the Sunday given you take the daily. And we saw that percent was 62.5%. And down here, if I would write this in, this would be the probability that a person would not take the Sunday, I'll use a prime there, given the fact they take the daily. Need a little more room. Okay, so you see the conditional probabilities are going to be probabilities along the second level of one of these decision trees. Now, notice another interesting thing that happens here. If we look at the product along this branch, what are we going to get? Well, we get 160 over 400. That's an awkward way of writing 40%. And what about the conditional probability? The conditional probability was 100 over 160. Okay, now notice what's going to happen here. This 160 cancels with that 160. This leaves 100 over 400, which is 25%, which notice was exactly what we had when we found the probability a person was a daily and Sunday. And in fact, that's not an accident. I'll just say D and S because I don't have much room there. Okay, that's not much of an accident. In fact, if I can go and express the general relationship down here, what we've actually illustrated here is that if we have two events, E and F, say, then the probability of E and F is just going to be, that would be like daily and Sunday, is going to be the product of the probability of, say, E, probability of daily, times the probability of F given E. Okay, and so this is a very fundamental condition here about conditional probability. It could actually be used as a definition of conditional probability if you know the probability of E and F and E, or if you know the conditional probability, it can be used as a way to compute the joint probability, the way we illustrated along the branch of that tree.